So, hello everybody. I was actually asked to wait a little bit because you never know when if everybody's there, yes or no. But thanks for being here. Thanks for tuning in to this webinar about one of the new features that we introduced in Axon Framework 4.6, and that new feature is the dead letter queue. You might know me, or you might not. For those who don't, I'm Steven. I have been working for Exonic since the start of Exonic, really, and I'm the lead developer for the framework. So I've had a lot of active development when it comes to the API and defining how this dead letter queue looks and feels. So I will be doing a bit of the explanation, the theory behind it, and what it is, and why we build it, and also do a little bit of live coding. You should have the option to ask questions because there's a chat window. I have that chat window in front of me as well. I will be looking at those at the end though. So I'll keep a move on when it comes to the material, going through the slide deck, going through the code, and then at the end I will check them. I will mark them so that everybody can see the question I'm talking about, and then we'll go over it. This is about 1 hour length of session. In all honesty, I didn't time it myself, although I'm confident we should be able to manage it within an hour. I'm guessing a little bit under it, actually. So you get a bit more of your own time back. But we'll see. So, again, happy to see everybody here. Let's head on into the dead letter queue. And what I'll start off with, actually, is get us on the same page of what this actually is. Because this is literally the exercise that I did. You know, you had a feeling, or I had a feeling for what a dead letter queue is. But what is the actual definition? What this meant with this tool? And first and foremost, you end up with what a dead letter actually is. And this is the most two-point definition I felt that I found. That it's an item that cannot be delivered or to its intended recipient. And after some time, the sender, it is either returned to the sender or destroyed. So, okay, that's a dead letter. So what's a dead letter queue then? Again, this is a noun, and it's a service implementation to store messages that meet one or more of the following criteria. This actually will give you a list of about 7 to 10 criteria, but the most important for our use case is that the message is not processed successfully, because surely there's a notion of it not arriving at the end source, but that's not really the focus from within the framework. Where the focus lies within the framework revolves a bit around all the event handling logic that we provide. So let's first have a common understanding of what that would mean, building an application with Axon and where your components reside. So we can state that we have some number of event handling components. These are the classes containing the event handling functions that you write. So the functions that you annotate with at event handler. You have made them part of your application context in a Spring environment or registered them as part of event handlers. So this is the code that you write, these event handling components. Now, these event handling components are grouped in so-called processing groups. And it's these processing groups that you can configure on, but you don't really build yourself. You don't have to do that. If you really want to, you can, but it's not a necessity because the framework provides these for you. It's the processing groups that do the sequencing logic specific for parallel processing that you want to have events handled in specific sequences. And there's a layer of error handling involved on this layer as well. And it's these processing groups that are again grouped into so-called event processors. And this is one of the things that you've likely played around with, that you've switched from tracking to pooled streaming or to a subscribing instance, because those are the event processor implementations that we provide. It is here that we provide the threading logic, the way how you receive your messages, and there's another layer of error handling in here. So when we started thinking about a dead letter queue, we needed to place it somewhere within these layers. The event handling component was, well, very obviously not the right place because that is the thing you write. That's something you could have already done. That's not really us providing something to you. What we end up doing is putting it into the processing group layer. And the specific bit why we did that is because of the sequencing, which is very important. And I'll come to that in a little bit, why this is so important. So here I have a different diagram when we're using a dead letter queue in an Axon-based application. On the left, we have a very simplified notation of what an event store might be. We have some events in them that are ordered based on their numbers, and they are belonging to several, well, groups, essentially. We got some events belonging to A, which are ordered again, belonging to C and D and E, well, all different sequences, so you will. If we're handling an event, the process is that the event processor receives that event, gives it to the processing group, then gives it to the event handling component, and your event handling component is likely doing something by updating it in a query model, or you're notifying something. But 9 out of 10, you're dealing with storing your model into a store. Now, we're handling some events. We flow through, well, I can actually do that again. We flow through the event stream, going to, well, ending up at event 4, and then we end up at event 5, and something's wrong. Either the format of your event is wrong, maybe the processing group has an issue, maybe your store is down, or maybe something in your event handling code goes wrong. Now, it doesn't really matter. There is an issue. Now, that issue causes your event handling component to break, your processing group to break, ending up in your error handling over there, but likely bubbling it up to your event processor. This means that your event processor is stuck. You either need to configure it to move over to a following step, or, well, it will just stall there. We know that we're building applications like this. We are already eventually consistent by breaking it apart, which gives us a lot of flexibility, but being stuck just makes that a bit longer. We don't want that. We want you to have a more pleasant journey with doing this. This is where the dead letter queue comes in. So let me adjust the diagram by replacing that processing group by a specific dead lettering processing group. So if you recall, it's the processing group where we implemented this, and we provided a specific variant of that processing group in essence. This dead lettering processing group has a separate store that it stores the dead letters in, and this is the actual dead letter queue that you would configure. This can be in memory or actually persisted, but it has that dead letter queue to communicate with. So let's do the exact same exercise. We're handling our events going from A1, B1, C1 to A2, and we end up at the faulty event D1 again. Now, our event handling component, the thing you write, would still blow up, but the exception will be caught by the dead lettering processing group, and it will store that event in the dead letter queue. Okay, well, that's nice. So now we can actually proceed. We're not stuck anymore. We've put it in the dead letter queue so we can start processing at a later stage. We can retry those failures at a later moment in time. So we go to event 6, all works fine. We end up at D2, and there's something important about D2 because it belongs to event D1. In essence, when you're handling your events and there's a certain sequence attached to those, you expect previous events in that sequence to be handled. You don't want things to come out of order. So we don't only want to enqueue D1, we want to enqueue that entire sequence starting from that point. And that is exactly what our dead lettering processing group does. It doesn't only store D1, it will also store D2 and D3. So we don't necessarily have a dead letter queue. We have a sequenced dead letter queue, essentially a queue of sequences. And we do this to maintain the ordering of the events, of the messages. To further ingrain this thought, I have this following diagram, focusing a little bit on the dead lettering processing group. It means that we don't have a single queue. No, we have, any number of queues, really. Honesty, from a configuration perspective, there is a maximum number of queues because you wouldn't want to duplicate your event store into a dead letter queue. That is problematic on its own accord. So you want to be a bit protective in that space. But by default, it can carry a ton of these, a lot of these at least. So you'll have separate of these sequences, which is here displayed by having the sequences H, D, and F, and potentially more. Now, let's put this in text a little bit as well. So the dead letter queue in Axon is really a queue of sequenced messages to ensure the messages are not handled out of order. So that whenever you do start processing letters from the queue, you essentially process sequences from the queue. By default, specifically from the event handling perspective, the sequencing is decided on by the sequencing policy, which is what the processing group already does. By default, this is sequence per aggregate identifier. You can, however, adjust this if you will. You can change the sequencing policy, essentially adjusting how your your event handling is parallelized. But by default, you will be doing sequence per aggregate. So this revolves around a sequence dead letter queue implementation, although throughout the exercise of this webinar and our documentation online, we typically call it the dead letter queue. It being sequenced is a very good benefit, which we feel is the reason why it is good to provide. But for simplicity's sake, we call it the dead letter queue. Currently, we have an in-memory variant, a JPA variant. We're working on JDBC, and the MongoDB variant is finished actually, but the Mongo extension hasn't been released yet. So you should be able to use that soon, hopefully start of next year actually, but it's not there yet. So I see a request from you, Indriyat Kumar. I'll put the questions for the slide deck at the end, if that's okay with you. So we got our dead letter queue in Axon. Let's look at how we're going to configure this thing. This is actually what I'm going to do in the coding exercise as well, but getting a little bit of a feel. So up top here, we're doing the non-Spring configuration here. I want you to see the non-Spring configuration as well, because it might be valuable for you one day if you don't want to use Spring. When you're doing this, you would be required to create the configurer from the framework. You would do some configuration options in the middle, and at a certain stage, you end up at, I want to configure my event processing logic, so the processing group specifics. This has a registered dead letter queue, and this is the way to get a dead letter queue out there. You cannot register a default dead letter queue for all your processors, because we do feel it's kind of a hefty tool. It's very good to use, but use it with caution. Be certain that you use it at the right places. So when you want to configure this, you can now only configure it for specific processing groups. So you're inclined to provide the processing group name you want to configure it for. Then you are requested to provide a function that ingests Axon's configuration, and then you are requested to return a sequence dead letter queue implementation, specifically of event message, as you see here. I've moved that to a static method that builds a very plain JPA sequence dead letter queue, providing you the processing group. And these are the hard requirements you need to give. You need to have an entity manager provider and a transaction manager, and we need to be able to serialize those dead letters to be able to store them. It's on this level that you also can configure the size of your queue and the number of sequences you're allowed to give, which I'll also show in a bit. So we got a dead letter queue. This is nice. But there are additional things that we want to configure on these components. We not only want just everything to be enqueued, but it is the default though. The framework cannot automatically deduce what your reason would be to put a letter in a queue or a failed event into a queue. So by default, any message is enqueued on an exception or a failed retry when you're processing those dead letters at a later stage. If you want to have power over this, if you want to adjust when we actually insert dead letters into the queue, you need to provide a so-called enqueue policy. The enqueue policy validates the dead letter that the dead letter processing group has given and the actual exception at that moment in time, and requests you to return a decision. This specifically resolves itself to a functional interface where you see what can be done for any type of message, although 9 out of 10, you will be doing this for events. You're given the letter and the cause, and you're requested to return an enqueue decision. So let's actually have a deeper look at this as well. So yeah, as I pointed out, the enqueue decision deduces whether you want the dead letter to be enqueued, yes or no. That is the thing you're doing that based on. So we have a custom implementation of an enqueue policy. As it is a functional interface, you could make it a Lambda, but for clarity, I've been doing it as such. And this custom enqueue policy does something based on retries. So it stores a notion of retries, and it is used to later deduce what to do. There are a couple of interesting bits in this example, which I'll further show as well in the coding section. The decisions, static methods I'm using here to enqueue and evict and requeue are provided for you, giving you the reasonable defaults of the enqueue decision implementations. If you want, you can make your own enqueue decision, but it is an interface, so you'll need to make a concrete implementation. These decisions give you an enqueue, an evict, and a requeue, and a do not enqueue implementation with a couple of additional benefits for you. We see at the first case, for example, if there are 0 retries, we enqueue with the cause so that we actually store it. And we do something that we provide metadata. It's this metadata that is the second interesting bit, because it allows you to add so-called diagnostic information to the dead letters that you store. It's these diagnostics that you can use to append any type of information that you think is valuable for your dead letters. The framework will, by default, don't add any diagnostics. We have had a very long debate about this, whether we should by default give you retries, by default give you the entire stack trace, by default do all kinds of other fancy bits. But we ended up every time in a discussion thinking, well, are we actually certain that every user needs this? Aren't we not being redundant if we add all these components? So for a first stab, we've decided not to do that. The diagnostics are empty. If you want to introduce diagnostics, you are required to provide an enqueue policy and to set the diagnostics on the decision that you're returning. So the enqueue decision is used for, well, roughly 2 things. It says, yes, I want to enqueue, or no, I don't want to enqueue. If the answer is yes, then it states, I want you to be enqueued with this cause and these diagnostic information. So that's what I'm doing in this custom implementation as well. If I already have a number of retries and it's not above 5, then I know I want to retry it again. But I want to increment the amount of retries, and I do that by retrieving the diagnostics from the letter. This is a lambda giving you the letter at that moment in time, and then appending it with the retries adjusted value. All right. To configure this, we're going back to the configuration solution we've just seen. You'll one way or another have the configurer and then have the event processing configurer from that. You can register a dead letter policy based on the processing group. For the dead letter policy, you can also register the default policy for any component using a dead letter queue, if you will. Okay, we've now looked at actually configuring the dead letter queue, what it would mean, and how you can deduce when it should enqueue or when it should not enqueue, and what kind of diagnostics you would have there. There's one big misser still, and that's how you get those letters from the queue to process them again. And it's this processing which is also a relatively tough bit to get right, because it's retrying means that the framework needs to invoke your event handling components within the group they belong to, again, in the right order. This is why that sequencing is also so important. So we provided a lot of tooling for this as well, so that you can select the right letters. We also do not automatically process your dead letters for you. This is a similar scenario with the diagnostics. We could conjure up any amount of scenarios where it would be feasible, but it would similarly not be feasible to retry your dead letters. So we don't do this. If you want to retry your dead letters, you will need to do this yourself. So as long as you're registering a dead letter queue and that's it, that means you're filling up your dead letter queue, and eventually exceptions will occur because you're not processing those dead letters. Now, this is not to say that this will be the scenario till the end of time. Likely, we will eventually provide some common defaults, like a scheduled retry process. Similarly, as I expected, we will provide some defaults for those enqueue policies based on retries or based on certain exception filters, stuff like that. Right now, though, for the first case, in 4.6, this is what it is. So if you have some suggestions in this space, feel free to actually draft up an issue on our on the GitHub repository. We can discuss it and see how we can make something that works well. So back to actually processing those dead letters. For this, we have a so-called sequenced dead letter processor. And it's again attached sequenced because we're processing an entire sequence. You're not processing singular letters. No, if you tell the dead letter processor to process something, it'll process the entire sequence that is a part of it. these sequence letter processors are exposed through the event processing configuration. This is slightly different from Axon's configurers because the configuration is the fulfilled configurer, containing every being the framework has built for you, every component the framework has built for you. It's a sequence letter processor that allows you to process a sequence based on a predicate. It will actually look like so. This is the actual interface. I emitted the Java doc for you because you can see that online if you will. You see that this also just works on any type of message, really, although the plain solution that you will use 9 out of 10 is based on events. You can process based on a predicate, filtering a sequence, or you can process whatever you like. You don't have any control over it. It's this predicate that you can use to very specifically trigger certain sequences, or very specifically trigger all the sequences for a given exception, or that have been retried 4 times, if you see fit. But it's this bit, this interface, these methods that you need to invoke. So we'll actually see that as well in a bit. So, yeah, as pointed out, again, I want to emphasize this very strongly. They process a single sequence, not a number of sequences. By the way, I do see your questions. I'm very deliberately waiting till the demo moment. So, if you want to retrieve that sequence letter processor, you will be using the event processing configuration, as I put it, and you're providing the processing group name you want the letter processor for, because the framework will make such a sequence letter processor for every processing group that has a letter queue. It returns an optional, which means that if the optional is empty, that there is no letter queue registered for that processing group. So you're guarded somewhat against this here. With that in hand, if it is present, you can either process anything you like, or you can process a given letter based on the existence of retries, for example, or whatever you feel is beneficial in your scenario. Now, this is actually my moment I had when it came to showcasing the slide deck. So we can move to code. But as I pointed out, I want to look at the questions just a little bit so that we're all on the same page. The first question we got was from Andriette Kumar. Are you want to say that number of queue is equal to that letter queue? I wouldn't necessarily follow that question correctly. The number of queue is equal. So if the number of sequences, I'd say, so the letter queue is not an infinite storage. It is not intended to copy over your entire event store. So we protect you against this. We block you at a certain maximum, and I believe the maximum is 1024 sequences with 1024 unique letters per sequence. That is the max. You can change those numbers. So there isn't necessarily a scenario where the letter queue, well, sequence count equals the actual sequences you have in your event store. That also highly depends on the exceptions you get. If your event handlers only fail for sequence foo and they succeed for sequence bar, then by definition, those would not, well, be equal. So that differs. I hope that answers your question, Adrit Kumar. I see a reply, but from someone else. Let's go to Jacob Hatzel. Hey, hello, Jacob. Nice to see you. Is there an Axon server backend letter queue planned? Right now, there isn't, Jacob. And we've done that somewhat deliberately because we're trying to feel that Axon server is in the space of being a message bus for distributed scenarios and an event store. It's not really intended as, well, similarly, it's not intended as a token store or a Saga store, or in that case, a letter store. That's not to say that we'll stick to that point in view forever, but for now, it's not really scheduled yet. But if you do have that request, keep them coming in because, well, it is still the users that drive our intent of what we're building. So, okay, let's move to Frank Scheffer as well. I would assume since the DLQ is focused on event handling side, including the token storage, this is independent of Axon server, isn't it? That's completely correct, Frank. Is independent from Axon server, especially because we want those letter queues to be stored in the same transaction as your token. So we saw earlier, what the letter queue does is unblock us. If an event fails, we don't just blow up. No, we proceed to the following event. This means the token needs to proceed as well through the sequence, through the event stream. So you'd want your dead letters to be stored next to your tokens, just as you would have your query model stored next to your tokens, so that you have a single database with a single transaction and don't distribute that. Also, in part, why putting it in an Axon server is not ideal, because if we put it in an Axon server and then have the token separate, then we have two transactions again, which we cannot guarantee. We don't want to come into the space of distributed transactions. Okay, I see a request from Jacob again. I'm just going to highlight it for everybody. That's true. This is really a communication between Jacob and Frank going on. Storing that type of information. Planned. Yes, Jacob. Yeah, what we are doing right now with the JPA variant, and I'll show it in a little bit, is that we are essentially copying the events. We're not doing references. That is also with intent, because we cannot be certain that users are using the same type of storage for the dead letters as they are for their events. Similarly, we honestly don't want those databases to be mixed in all cases, so it makes it a bit more complex. So let's move over to Ethan. So, hi Ethan, welcome. Would a useful DLQ need an Axon configuration where the default error handler is replaced with a propagating error handler? A very good question, Ethan. In actuality, the listener invocation error handler you would use on your processing group configuration is no longer configurable when you're using the dead letter queue. If you register a dead letter queue for a given processing group, we replace that entire processing group for a specific dead lettering processing group. And we want to capture all the exceptions and have that enqueue decision be the decisive factor whether you put it in the queue, yes or no, whether you proceed or fail. So the listener invocation error handler configuration for your processing group doesn't really do anything at this stage anymore. Maybe we'll change that in the future, that you have some form of work, but for right now, we feel that the enqueue policy is sufficient. If you're talking about the error handler, so the error handling on the event processor, that's a bit different. That's still something you can configure, which is important as well. Because if you fail storing something in your dead letter queue, you would still get an exception that needs to bubble up to the event processor that needs to deduce what to do further with it. I hope that is clear. Let's move over to Hamed. Hi, I hope I'm saying your name correctly. Is there additional configuration to be done when we are trying to handle events coming from different Axon server contexts? No, not necessarily, Hamed. So this dead letter queue is, as a processing group, it receives the events from the event processor, and it leaves that job with the event processor completely. And it's the event processor which you can configure on where the events come from, what the source is. So if you have several contexts and you have combined those in the so-called multi-streamable message source, then it's the event processor having that. The dead letter queue doesn't have a clue about that. It'll just get events and it'll be fine with that. It'll store all the required bits to make it work. So there's no additional configuration to be done here, other than the configuration you already have on your event processor to merge those contexts into a single one. Again, I hope that answers the question. So we move over to Frank again. Frank Scheffler. Does Axon ensure that that letter queue diagnostics, such as retry count, are stored persistently, albeit the handling transaction being rolled back as part of the error handling? So this is also highlighting an interesting point. So the event handling transaction is not rolled back when you're using that letter queue. And that is, we're essentially tailing the transaction that is used for updating the token and thus inserting the dead letter into the queue. This means that if you're updating two repositories or query models in one go and one of them succeeds, that one will still succeed. This is why your event handlers need to be idempotent when you start using the dead letter queue. We have a separate section in the reference guide on this, making this clear. And this is in part why I wanted to have this session, to make it overly clear again. Your event handlers simply need to be idempotent, or you need to be able, one way or another, need to be able to deal that some of your projections might have been updated twice. So don't simply do an increment. No, compare with the previous value before you do things like that. So the diagnostics are still simply stored as they're part of the dead letter itself, the dead letter entry that is stored, that is by definition not really rolled back. I really hope that answers your question, Frank. And if not, just drop another chat request in the chat. So we're almost there at the end, I hope. So we move to Jaroslav Schnaubat. Is it possible to set up default sequenced dead letter processor? No, it is not right now. And that should actually be doable. Right now, you just get, well, you can make one. I've somewhat built one of these. This is actually a good idea. Right now, no, we can definitely build this. If you would want, you can make an issue for this, Jaroslav, that you get the credits somewhat for making that issue. If you want to provide a pull request, that would be even more awesome. And granted, you need to have the time for that, but we're always very willing to see additional logic. Frank has another question about upcasters. Is upcasting integrated with that letter queue? That is, are events copied over to the DL queue in which state, upcasted or not? And would the upcaster chain be called when they're handling the queued messages again? This is similarly a good question. Our first idea, Frank, was to have the event upcaster chain be part of the dead letter queue implementation so that we'd always have the original format and upcasted it to the new one. For now, we have decided against that. That is in part for getting the feature out and used by users to actually see whether we need that. And also in part because we'd hope that your dead letters aren't stored there for a very long time. They are a means to offload your, production, the people that are maintaining your application in a production environment that might be called out of bed, like I can be for Axon Server, that they have a little bit more leniency, that there's a bit more freedom before they actually need to jump on the call. The chances, furthermore, that the events format is the issue are hopefully very limited. So if you actually have a production outage that causes your dead letter queue to require a new release, we expect that to be more of a hot fix just for that specific scenario. If it is in the scope of the actual structure of the event, then right now the recommendation would be to make your events compatible with the new and the old version. That means you don't remove or delete fields, you deprecate them and replace them for the new stuff so that you can work with the faulty version, the version before, and the new version. Granted, we are basing ourselves a little bit on assumptions here. There actually is already an open issue for this from another user. So if you really feel for this and you think you have a production scenario where you really need this, please start the issue or put a thumbs up that you want this, because it would be very valuable information for us to know. Okay, so we go to Parsifal. How do you configure the time exponential backoff or fixed between retries? Parsifal. So we don't retry the dead letters for you. You need to do that. So you have complete power of deducing how you retry those, how frequent you retry those, if you do that with an exponential retry. And you'll see in a little bit how you could do that. I see Danielle tapping in. Hi, Danielle. Long time no see, although I don't really see you, but nice that you're here. Is the payload of the event stored in the dead letter queues or simply no? So I hope that became apparent just now. We're storing the entire event in its serialized format. Actually, not your payload, but the event message that the framework uses, so that we have all the goodies like the tracking token therein as well. And we'll see that in a little bit. Again, this has been a point of discussion, but we simply cannot be 100% certain that you're using the same storage method for your events as you are using for this, making it a bit complex to have pointers. So we went for the simple right now for copying. In essence, also why you don't want your dead letter queue to be infinitely large. That would be an issue. I see Oystein. Hi, Oystein. Again, nice to see you here. Why is a serializer needed? Why aren't events copied as is from the event stream? Because we want to store them in a serialized fashion. and we don't have them at this stage. That's likely the better answer. If we would be in the scope of the event processor, we could work with still the unserialized format. We could get that out of it. But as soon as we're in the processing group, we are certain it's already been deserialized at that stage. We might have a lazy instance that we can work with, but well, that's likely not the case. Furthermore, we also need to serialize it to serialize your diagnostic information that you might be adding, because that is just metadata. It needs to be serialized into a string. We cannot have that collection stored in one go. So that would be a definite requirement for events. We could likely work around it. We went for a serializer there. We can go to Nefri Suswati. Hello as well. If something goes wrong in event processor, can we make DLQ handle that as well? Not right now, Nefri. If something goes wrong in the event processor, that typically means that there's an issue with committing your transaction. And if there's an issue with committing your transaction, then there's also nothing you can really store in that letter queue, because that needs to be persisted as well. So if something really goes wrong in your event processor, there is still an all hands on deck scenario for your production environment. Sorry. Not really sure if we can solve that right now. Perhaps we come up with something in the future. Johnny T. Hi, Johannes. Nice to see you. What happens if there are some entries in the dead letter queue and the full replay is done? Would the dead letter queue replay lead to a second replay of the... This is also a very nice question, actually. This is configurable. The dead lettering processing group is actually the bit that would invoke the rehandling of your events, but it's also the bit that deduces whether it should be able to replay, yes or no. By default, I'm not 100% sure what it does by default, but this is the right moment to actually move to code. So I can show that right away. So let's move. And what I want to have is that lettering processing group. And of course it doesn't have that right now. Ah, lovely. Here then, right? Always nice. Always the unexpected questions, which makes it a bit more interesting. But that's good, you know? Keeps me on my toes. I think it is here. Yeah, that lettering. Event handler invoker. You might think, but you were talking about the processing group. Well, the event handler invoker is the processing group. The allow reset from the builder is default to false. So by default, it will not replay when you're actually replaying or resetting your token. If you do want that, well, you can configure it so to do this, which you can adjust on the processing task. Could you please switch to your own camera? I'm not sure I understand that question, Aryo. I hope. Can you see me? I have a laptop screen down below, and this is where I see the chat window. And I have my camera up top, which is the good camera, which is HD quality instead of my laptop camera. So it might be a bit off. My apologies. I intend to watch at all of you. Yeah, sorry for that. I'll do my best right now. So let's actually go to some code, right? Let's start with our application. For those who have seen me do demos before, I tend to use a demo I have built in my own personal environment, in my own GitHub repository, which is about game rentals. So this is an application I've been tailing around with several steps. Those steps are all part of the README. I have done my best to make the README pretty thorough, so that you can follow these steps if you want. There's a description in here stating that I change it through the recordings, and there are the separate steps you can go for. These steps are all separate branches in the repository, so you can move from step 1 to 10. And right now we're at step 10. The actual adjustments of making this dead letterable aren't pushed yet, so bear with me. I will push that right after this session, so it really is a little bit live. I do have some of the things already. For those who are not aware of this application, what it does, it allows you to register a game, rent a game, and return a game. So that revolves around having a very basic command package with a game aggregate in it that has all that logic. This is accessed through a REST controller and perhaps also an RSocket controller if you like. The REST controller just allows you to create. I'm using a reactive gateway over here to do all that. Next to the game aggregate, there's a query model, which is has a game catalog projector projecting the catalog into this game view and a game view repository, which can also be retrieved from the REST controller on find operations. Now, what I have added here is an additional query end, which I've called reservations. So this reservations is a means, I figured it might be reasonable. Let's assume you go to a shop to rent out a game, but the game is out of stock. It's not there yet. So you're put on a list. So what we do is whenever a game is returned, we'll notify the reservation service that the game is available. So that's what we'll do. But you might have guessed it, this is a flunky implementation. There is one, but for whatever reason, it does a random int, and every modulo 10, it throws an exception. Obviously not very reasonable, but this is, for me, a very easy way to showcase what happens when it fails and how we do all that. So it's this flunky reservation service implementation that is used by the reservation notifier, a specific processing group, as you can see. There's also a specific profile attached to it, so I can toggle it on and off, and it just notifies when a game is available. Okay. Now, as we know, this service might fail. Third-party service invocations might be a reasonable place to do this with, so we'll want to configure a sequence data queue for the reservations processing group. So let's do that. We'll move to the application config, and what I'm going to introduce is a configurer module. So I'll add some additional space that we're all looking at the same bit. I'm going to add a bean, which I'm going to call the configurer module, which is a configurer module instance. And configurer modules are components that the framework will attach to the overall configurer, and will invoke them once you'll start the configuration. So this is how we can append additional configuration logic in a Spring environment. In the past, you might have seen add auto-wired annotations, but Spring's recent bit more strict circular dependency logic makes it a bit more problematic. Configurer modules will ensure you that they do work 9 out of 10. So I'd recommend you to do this. Configurer module. What we get here is, well, actually, this is just a lambda, which we're going to return. We'll get to the configurer. On the configurer, we'll retrieve the event processing configuration, and we'll register that letter queue. So this requires two parameters, being the processing group and the queue builder. Now that processing group I already had copied, and we'll go to return builder for the JPA sequence that letter queue. So builder and build, and we actually have a working instance. This will obviously not work. If you ever wonder what the required fields for any of these builders are, please just open the documentation of the builder method. It tells you that what is required. As you can see, the processing group, transaction manager, serializer, and entity manager provider are hard requirements to make this queue work. We do this throughout all our builders, to be clear to you. Okay, so we'll add the processing group. We'll add the serializer, for which I'll use the event serializer, because I'll be storing events. The transaction manager can come from the components in the configuration. Don't necessarily care. I want to default from the framework, and we can do the same for the entity manager provider. Entity manager class. Okay, so now we got our plain JPA that letter queue configured. Let's also add the idea of not always retrying indefinitely. We want to have our own enqueue policy. So I'm going to add a separate class for this. Normally, I would likely do this in the Lambda as well, but I don't think it's very clear from a demoing perspective. So I'll add a retry constraint enqueue. Let's see, class. Let's move this guy, constraints with a typo, because we're doing live demos after all. Implements the enqueue policy for an event message. Then you again need to provide what's in here. It can be an event message of anything, so just use a wildcard over there. We're going to decide method that gives us that letter and the cause, as you can see. We can add some of the logic. Well, first, diagnostics. This is, well, the metadata instance, as you can see, that we get from the diagnostics. The diagnostics are simply just the same metadata objects you could have on your commands or your events or your queries. We'll just be using them for dead letters as well. So these have the regular operations of get or default, actually coming from the maps here. So whenever we have a retry and it's not there, we default to 0. We want this to be... So it's pretty cold in my house, so my hands are very cold actually, making the typing extremely annoying. I'll bear with you. Oh, I've promised to do it then, whatever. So I'm going to do a roughly similar thing as we've seen in the slide deck. I'm going to use the decisions static operation. As I pointed out, this is a utility class providing a number of reasonable enqueue decisions for you. So if we actually move into this, you can see that there's a, if we want to ignore, do not enqueue, evict, all going to actual implementations that do something. This is just for your benefit. You can provide your own enqueue decisions if you will. We definitely want to enqueue on this case. We want to give a cause. We definitely want to share the reason why we're actually introducing this. We also want to have diagnostics in there. So you see that this is a function based on the letter you are enqueuing and then giving some metadata. Well, in this scenario, we know that this is a new instance. So we do an entirely new instance of retries and then 0 in this case. Now, else if retries is larger than 5 or 42. I think 42 is nice. We do another one. We then evict the entry. We don't want it to be stored anymore. So this means that you can, well, essentially throw away your dead letters, like we've seen from the original definition of what the dead letter is. It's either return to sender or it is, well, just thrown away. Bigger than that, then we have a requeue scenario. We do decisions.requeue, also calls. As we're requeuing, we want to use the original metadata. So we do letter.and, and we are lazy developers, as we all know. So we do retries +1. Okay. We saw a question popping up. Oh, Yaroslav, we can see you perfectly. Okay, awesome. Happy to hear that. That's good. Let's highlight it a little bit. I was referring to Yaroslav over here. Let's move to Nefri. Based on the provided error context object, you can decide to ignore the error, schedule retries, perform. How to do it? You mean the error context in the error handler of the event processor right now. So the predicament why we decided against doing it over there in Nefri is because you cannot maintain the sequences. The sequencing logic is in the processing group. It's not in the event processor. So you don't get a single event. You get a list of events that are failed. So your entire batch. So you need to, well, either schedule your entire batch for a retry or not. We don't feel, you can do it, surely, but it is complex. I've tried that API, and for a reason I went to doing this on the processing group level. Also, dealing with the exceptions that are thrown from your event handlers will catch 9 out of 10 scenarios. The actual issues with your database are not something that's easily, that's just invoking an entire retry of the entire process. I think it's a little bit out of scope. Please put that, maybe if we have time at the end, I'll cover it. But for right now, I want to focus on the retry policies, the data queue in that fashion on the processor group level. Please bear with me, Nefri. Our retry constraint enqueue policy. All those words. We're going to configure this over here. So we're going to add another configure module. We could do it in the same, but I feel like adding another one. So public configure module, enqueue policy configure module. That I show some additional things from this. So we can do the letter policy, but we can do register dead letter policy, or we can do a default dead letter policy, if I'm correct. I've built this, right? Yeah, here it is, default dead letter policy. So we can just provide an entire function. I think that's okay. do that. We'll make a new instance of this. Now, there are some other things you can also configure when it comes to dead letters, which might be interesting. So we got a default dead letter policy, the dead letter queue, and we should dead lettering event handler invoker configuration. This is the bit I want to show. So Johnny, or Johannes as I know, had a very good question actually. He was wondering if a retry would happen. Now, you need to configure the actual event handler invoker to do that. But that's not a thing you would typically access. So the way to access that is by using this dead lettering event handler invoker configuration. You can just, I believe this is it. And this is an actual Lambda as well. So you have the opportunity to tie into the builder actually. So here you can set it to true. Might be a bit quick, but you do have the capability to adjust these things. So I wanted to give that. Now, to remove this, we make this compilable code. All right. So, okay. So, one remaining point. Yes, where's retry set? Which other metadata bars can read out of diagnostics? Okay, let's fair. Let's show that for everybody to see what I'm sharing about. So the retries are set actually here for a first in queue and here when you're requeuing. So to make that a bit more clear, we can move into the in-queue decision. You see that it dictates whether it should in-queue, whether you want to in-queue with a cause, because you're not inclined to provide the reason for it. That's a choice. And you can say what the diagnostics are going to be. The framework will invoke the with diagnostics method for you. So it will set the letter and it will allow you to adjust the diagnostics of that letter, just the diagnostics. So that is what these in-queue decisions also do. If you have the should in-queue, you see you have a diagnostic builder, ingesting a letter and returning the metadata. And that's what I'm doing in that retry constraint in-queue policy. I'm ingesting a letter and giving the metadata I want to return. And this is, right now, this is all the metadata that's set, nothing more. The framework doesn't do any of this by default yet. Common scenarios like retries might eventually make it into the framework, but we've decided against that for the first implementation. Move over to actually processing these things, because in the time I have left, I also want to show that. So I've provided the dead letter management controller that we can actually trigger the processing of dead letters. Remember, this is your job right now, because we weren't 100% sure what all the scenarios would be you would be conjuring up. We decided we give you the flexibility, and we expect or hope that you would share with us what you think are the most reasonable ones, so we can eventually make those part of the framework. So be prevalent on GitHub, add those issues, giving your suggestions, giving your ideas, because otherwise we'd be working in the dark. So I've made a basic controller from a management perspective using a so-called dead letter processor. And it's this dead letter processor using the event processing configuration and having an executed service. Actually, I've already prepared this, and this will process a letter returning a completable future of Boolean. Well, okay, let's actually make this a working component so that we can run our application. So we do, this is where we can get to the sequence dead letter processor. You see we're inclined to provide the processing group, and this will return an optional. You see an optional sequence dead letter processor of an event message. We're not going to use this format because that's ugly. We're going to do a or else throw. Because if it's not there, well, then you're doing something wrong. Illegal argument exception seems fair. No DLQ configured for group. This is the correct syntax. Right. So if it is present, the letter processor. We have the letter processor that allows us to process any or process. You see it returns a Boolean. That Boolean dictates whether, well, you process the entire sequence successfully. So that is what we're going to use in a supply async. using that executor service. I'm similarly using an executor service here because if you're just directly invoking it, you're stalling that thread invoking your retry process or invoking that endpoint, which we don't want. So instead, we put it into an executor service using a completable future to get the result eventually. Okay, I think I should have a working application. So let's actually start this up. That's the wrong one. This should be the one I should be starting. Let's pray that the demo gods are nice enough to me. Okay, let's actually show this. Make it a bit smaller so that it fits on screen. If you're not able to see this, please share. We also already see some game registered events going by because I've prepared some events into the store. I'm, by the way, connecting to Axonic Cloud to get my application to work. See, our socket is there. We see our reservations processor that we've created. We see our game catalog that is still doing the catalog logic. All right, we've got some of our basics. Now, one of the other things I have in this project is some HTTP requests so we can actually see what's in there. So we can fetch the full catalog. And we should have a number of games. All right, this works. Now, the logic of actually invoking the notifiers behind the return operation. So what I've prepared for this additional step is a lot of renter returns. And luckily, IntelliJ gives me the option to run all of them. So let's run all of them. So we have 50 of these. All these operations work on the same game, actually. Everybody is very interested in playing Elden Ring, me included. If you are into video games, Elden Ring is very awesome. A bit difficult, but nice. But yeah, for whatever reason, everybody wants this game. It's very busy for Elden Ring. It's a very busy year. So got a ton of usages. Now, let's move back to the logging of our application because we actually should see a lot of exceptions right now. Or, well, it's actually some logging statements. See rent and return coming through. Reservations is also doing its thing, but it didn't fail for quite some time. That's because it only fails on a module 10 of a random number 100. Right now, though, we see an exception here. The JPA dead letter queue is adding an entry with the cannot reach the flunky service exception, all right, and inserting that. Now we see it inserted at index 0, and we should see that message popping up with incremental numbers for some time. Here it goes, number 1. Here goes index number 2. You might be wondering, why are they part of the same sequence? Well, because the sequencing policy by default is the sequence per aggregate identifier, and the identifier of this game, Elden Ring, is 9001. So everything is in the same processing group, or in the same sequence, my apology. So I've also got the database in here, because I felt that was applicable to show, because I don't have a view right now. This does also be a task to follow. If we move into the dead letter entries, we can see what we are storing. So we see that we got one event actually with a cause, and the rest we don't. Not having a cause, message, or type, or diagnostics in this case, means that it's an event in a following step of the sequence, so trailing something else. We can actually see that if we move to the end of this, that we have a sequence index storing that number. Going up to 40, we also see that we're storing a bunch of things, like whether we're processing or whether a processing group is, what the processing group is, all the logics about the event we're having, and the specific bits from the dead letter, when it was enqueued, when it was last touched, and the diagnostic information. Now it's here where I think I did something wrong because I've lost that one event, but c'est ça. Click something, right? This is interesting. Well, it doesn't matter. Let's actually proceed with the demo. Let's assume that we're going to process some of these letters. We're going to process any of them. We'll still get a false back because the processing of these letters would still end up with the flunky system that might fail some of the times. So that's also something we should be able to see. And we actually, well, we see the exception going through. This is not bubble up. It's really caught in a warn message right now. But we have handled a number. We see that we've claimed some evicting entries, processing another letter, evicting it again. So we will by default evict an entry if handling was successful, if you told it to process anything. But eventually it failed. So we can go to this set again. Well, I think I've reordered the events. One way or another. Yeah, that was it. Okay. That was it. Yeah, nice. Now we see the calls again. Now we see that the other, another event has that cause. And if we process again, we'll see that another of the entries should have that cause. All right, so now we're at index 24. We could keep this going, but I think you've got the gist. And actually, this is all I had. So as we're half a minute over time, thank you all for attending, actually. This was a pleasure. I really enjoyed doing a session like this. I actually want to do sessions like this a bit more often because showcasing the awesome stuff that we're building, I think that's something we should be doing, actually. So especially new features for the framework justify a showcase. So there are two links down below here. One is the game rental application. That is the thing I was just showing. So you can play around with it a little bit yourself and see and, well, use that if you will, if you like. And if you want to read up on the documentation of this, you need to go to the event processors page. So to make that painfully clear, move over to the cloud. Move over to a browser. So if you're on the reference guide, go to event processors. There's a dead letter queue section in here explaining in more detail, or, well, likely the similar level of detail as I've done, all these specifics, so you can go over them. Okay. Oh, I can actually share this as well in the chat right now. Oh no, my colleague was before me. All right. Then we can move back to this slide. Thanks, Stephen. Great session. Thanks for the kind words, everybody. I'll wish everybody a great evening. If there's no questions, if there is, I'll wait for a little bit. So fire away. No, I'm assuming that this was it. Okay, then yes. Thanks for the kind words, everybody. I hope this was pleasant. Also, if it wasn't pleasant or you feel we should adjust something, please just be as boldly honest if you want to be in the comment section. I'm from the Netherlands. I'm used to being very bold and harsh, so you can do that against me. No worries. I hope to see you in a future webinar like this, maybe even in person. Thanks for being here. Ciao.